राधे राधे एवरीवन। बताओ शुरू कर दूं? क्या मैं स्ट्रीमिंग शुरू कर दूं? क्या मुझे स्ट्रीमिंग शुरू कर देना चाहिए? क्या आप लोगों को लगता है कि मुझे स्ट्रीमिंग शुरू कर देना चाहिए? The problem is that not much people have joined actually. Anyways, I'm audible, right? Yeah, I'm audible. Anyways, I'm audible, right? Okay, कोई ना. Let's start. Till more people join, let's start. So the first problem was find the minimum log transportation cost. Okay. What does this mean? It means that there are two logs of length n and m units which needs to be transported in 3 trucks, where each truck can carry one log with length at most k units. Okay? You may cut the logs into smaller pieces where the cost of cutting a log of length x into logs of length okay, is called. Return the minimum total cost. It is already 9:30, right? It's 9:32. Otherwise, like I will be getting the flag now. Okay. Return the minimum total cost of to distribute all the logs from the trucks. If the logs don't need to be cut, total cost is 0. Okay. Great. Now see, it means that every log, first to easy भाई, third fourth stuff. अब मगर मैंने थर्ड फोर्थ किया नहीं है भाई. फर्स्ट मैंने किया एकदम पहले के 10 मिनट में और बस और कुछ कर नहीं पाया, तो वो मैं एडिटोरियल से देखूंगा. ठीक है. आज थोड़ा मतलब हो गया, लेट हो गया, संडे मॉर्निंग यू नो. Okay, sorry. So what does it mean? So what does that mean? It means that let's say if you are having a log, you can cut it into any number of pieces. Okay. But if you look at the problem again, it tells that n and m it is lesser than equal to 2 into k, which means it is lesser than twice of k. That means that no matter wherever you cut, both the pieces of log will be fit. Okay. Because since it is lesser than equal to 2k. Okay. Like if you cut it optimally, not wherever, sorry. If you cut it optimally, it will always be like the same number. Since it is, I'll explain it more easily. See, since its maximum value can be 2 into k. So what is its maximum half? It is 2k by 2. That is that is k, right? So which means that yeah, if I cut the log into one half, it is possible. I don't need to cut more than that. Okay, so that is the most optimal solution, to cut the log into only one half. Now, what you are going to cut it into, it depends upon like a differential equation. That is, this is x and this is n minus x. Okay, so you have to minimize the value of x into n minus x, right? You know like how to do that, ddx of that. Okay, then again check for ddx of that. Okay, and after you're done with that, so you will find that to maximize the value it will be n by 2. Okay, So what is the minim? What do we need to do to minimize the value? You have to make it as less as possible. Okay, that means कि अगर if the length of the log is a little bit greater than k, okay, so you will have one piece of k and the other piece of n minus k. Okay, one piece k and another piece n minus k, because that is the most optimal solution using differential equation. Okay, तो वही किया है मैंने, ऐसा कुछ है नहीं खास. ये मैंने while डाला है which is of no use. Let me tell you, this is of no use, absolutely no use. And इसमें मैंने while डाला है which is also of no use. This is like, even if I would have ignored this, then also it will work. Okay. You have to check if it is m is greater than k. That you have to check. So instead of while, you could have done like if. Okay. So if you go for if and if you submit the code, you will find that it is an accepted solution. Okay. So I don't think there is any doubt regarding this, because yeah, many of you have done it. Okay. Let's move on to the next problem. Resulting string after adjacent removals. You're given a string S containing lowercase English alphabets. You must repeatedly perform the following operation while the string S has at least two consecutive characters. Remove the leftmost pair of adjacent characters in the string that are consecutive in alphabet. A and B are consecutive, B and A are consecutive, A and Z are consecutive, Z and A are consecutive. Shift the remaining characters to the left to fill the gap. Return the resulting string after no more operations can be performed. Let's take a big example. Not this. Let's take this example. Uh, and try to understand what they actually mean. See, what is the most leftmost consecutive element? AD is not consecutive, DC is consecutive. So what we can do is we can remove this D. Sorry, I can't do that. So we can remove this D, okay, and then remove this C. Now what is remaining? AB, right? Now it becomes AB. Now AB is also consecutive, so we remove A and B. So now what is remaining? A blank, an empty string. Okay, so that is the smallest. I mean, that is the best thing that you can do. Okay, how to do it? It is very similar to stack, like the stack algorithm where you check for the balancedness of brackets. Okay, it is very similar to that. It is like whenever you find, so let's say ADCB. Let me take ADCB, and there is a stack. Okay, so first of all there is A, so I put that into the stack. Then there is a D, so I have to put that into the stack because D and A is not consecutive. I mean the peak element, the top element is not consecutive. Now C and D is consecutive, so I can pop it out. And then B and A is consecutive, so I can pop it out. So what is the length of the stack? It is 0. So it is basically nothing but it will be 0. I mean it's a null. Okay. Now if you take some other example, let's take this example ABC. Okay, it will be also simple, very much simple, I guess. So first of all, I put A into it. Then there is a B, so I can pop it out because A and B are consecutive. Then there is a C. There is a C. So what is the string? It is a normal C. Okay, it is a C. But if you go for Z A D B, okay. Now look at this. What happens over here? First of all, I put Z into it. Then I get a A. Now A and Z are consecutive, so I can remove the Z. Then I get a D. I put D into it. Then I get a B, but B and D is not consecutive, so I put a B into it. So what is the final string? It is DB. Okay. So I hope this is clear. I'll just move on to the code quickly. It is like you have a stack, iterate throughout all the elements and check if the stack is empty, then you have to push it. Otherwise, you have to check if the topmost element it is consecutive or not. If its absolute difference is 1, then it is consecutive. If it is A and Z, it is consecutive. If it's Z and A, it is consecutive. I've already told you about this scenario. If it is consecutive, then you have to pop out. And if it is not consecutive, then also you have to push. Okay. Then I'm using a string builder. So this is basically to make the complexity as big O n. Okay. So that it doesn't, you know what, like append function, if you do it on string in Java, it takes itself it takes big O1, but over here, sorry, big O N. So over here it takes big O1 if you do a append. Okay, so that's it, and it's been string. Okay, so I'm guessing that there is no problem regarding this also, right? Now I'm going to go into the problem which I haven't. You know what confused me the most? It was that I think you guys won't be able to see it unless I remove this. See, it was like five. This was 3 points. This was 4 points. This was 5 points, and this was 4 points again. So I moved on to the number, the last one. Okay, and then I moved on to the C. So I don't know like what the heck is this system, because usually they give it in a ascending order. I mean, they give it a non-decreasing order. Okay. Not a strictly increasing order, but an increasing order. They give the points. Okay. Anyway, so we are done with this. Now we are going to go to this. We'll go to the discuss. First of all, let's understand what the problem is. Maximum profits from trading stocks with discounts. You're given an integer n representing the number of employees in a company. Each employee is assigned a unique ID 1 to n, and employee 1 is the CEO. You are given one based index arrays, present and future, each of length n, where present I represent the current price at which ith employee can buy a stock today, and future I is the expected price at which he can sell the stock tomorrow. The company's hierarchy is presented by a 2D integer array hierarchy, where hierarchy u of I comma v of I means that employee u of I and is the direct boss of v of I. Additionally, you have an integer budget representing the total funds available for investment. However, the company has a discount policy. If an employee's direct boss purchases their own stock, then the employee can buy their stock at the half of the original price. So this is the part where like you have to find a tricky answer. You have to return the maximum profit that can be achieved without exceeding the given budget. See, if this was not there, in that case it will be very much easy for us, right? It is a normal 0 1 knapsack. But this thing, it actually does something to a 0 1 knapsack. So I'm assuming that the answer, the solution should be somewhat 0 1 knapsack only. Let's check. It will be it should be a modified form of 0 1 knapsack, I guess. Maybe wrong though. Okay, simple solution Java. Simple solution. With knapsack like DP on 3. Let's take the simple solution. My frame rate may be getting a little bit out of hand, as I can see, but my voice should be clear. क्या हो रहा है इसको कुछ भी नहीं रहा I think this is taking too much of traffic because my video is also lagging because of this. Is there anyone watching this video right now? If anyone is watching this, just can you tell me whether my voice is getting clear or not? Ask details book करो और hotels Goa and Vivo में book करो. Download now and get flat 25% off. Okay, my voice is clear, but my audio, I mean, my video was getting a little bit lagged. But now I think it is it's getting half. It's not even 30 FPS. Now it is okay, right? Now it is perfect. Okay, intuition approach time. Do you're simply given the solution. Okay, let's try to decode from the solution. See, max profit, int, n, int, free, int, future, int, whatever it is. Let me just do one. Just copy this. Paste this. Okay, this is the hierarchy and this is the budget. Then I'm having an adjacency array which is okay, and then for every edge I'm having the hierarchy, and I'm giving the I mean for every hierarchy I'm getting the edge, and I'm in the adjacency array I'm putting it. I'm having a map, I don't know what it is for. Then I'm performing a DFS from the CEO. Okay, because CEO is at the top. Then I'm returning maximum of 0 comma answer of what. Okay, so whichever is giving me maximum, it is basically nothing but answer of but. Answer, what is the answer? Achha, answer is what is getting returned by the DFS. Okay, so let's try to understand how, like, what is the modification he has done on the DFS. It is int u boolean distance, int pre future, everything else he has just copied. Minimum is equal to long minimum value by 2. Why did he do by 2? This was also more than enough, na? I think this was also more than enough. Then he's making the key as u plus dot distance. Okay, so this is basically nothing but he's just making a unique key for everyone. Okay, unique key for everyone. Okay, so the map, I think it is working as somewhat like a memoization. So if it is working as a memoization. If map dot contains key, return map dot get. Okay, so this is basically nothing but this is a memo. Okay, then we are having a DP and we are filling it with minimum value, and then we make DP of 0 is equal to 0, and then we go on doing for the remaining DPs. So DP 0 and DP, there are two DPs, DP and DP 0. Okay, then what we are going to do is for every specific adjacents that we get for every specific element, that is we are going to traverse throughout that. Basically it is nothing but the DFS thing. Okay, So long of child is equal to DFS of V false pre future adjacent bud map. Okay, nothing but like this only. V false pre future adjacent bud map. Okay, so V is the next node right now. That is the node that can be reached from U. Okay, so we reach the node of V from U, and then we make temp is equal to arrays dot copy of dp of 0 bud plus 1, and then for every bud what we do is dp of 0 of I is equal to minimum, then continue, otherwise j is equal to 0, j is lesser than equal to bud minus 1, bud minus I, j plus plus. This is basically nothing but bud minus I. Okay, in case you're getting confused what it is. If child of j not equal to min, then temp of I plus a is equal to this comma dp of 0 plus child of j. No man, this is not at all simple. This is not at all simple. I think we should skip this problem. Let's skip this problem, okay? Let's move on to the next problem. Lexicographically smallest string after adjacent removals. You're given a string S consisting of lowercase English letters. You can perform the following operations any number of times, including 0. Remove any pair of adjacent characters in the string that are consecutive in the alphabet. See, earlier in this case, okay, I have deleted it. So, in the previous question, what was happening? We were just removing the leftmost consecutive element. But over here it is given that you can remove any consecutive element, so that whatever the answer is, it has to be lexicographically smallest. Okay. So this is a challenging task. I don't know how they have done it. Don't look at my solution. It is very bad. Okay, I removed the discuss of this also. So let me just first of all go through the problem. So you can remove any pair of adjacent characters in a string that are consecutive in alphabets in either order A and B, B and A, and Z and A, and A and Z. Okay. Shift the remaining element to the left to fill the gap. Return the lexicographically smaller string that can be obtained after performing the operation optimally. String A is lexicographically smaller than B if the first position where A and B differs. String A has a letter that appears earlier in the alphabet than the corresponding letter in B. Okay. Otherwise, return whichever is minimum, A or B of length, whichever is of minimum length, A or B. Okay. So I'll just show you like how it differs from the first problem. Okay. So this lexicographical thing is already there. But apart from that, if you look at this one, okay, this one. First of all, I'll try to do it using whatever I had done earlier in the second problem. Okay, I take B, then C is consecutive, so I remove it. Then there is D, I put D, then A. Now A and D is not consecutive, so I put A. So what is the answer? It is going to be DA, right? It seems like Chinese. So it is going to be DA, right? But it won't be DA because let's say if it is B, C, D, A, I can remove this C and D also, no? I can remove the C and D also. Now that I can remove both this C and D, so what is I am left with? B and A. I can again remove B and A. Now it becomes an empty string. Okay. So that is how you have that is how it differs. So brute force to optimal DP seems like a good one. Let's give it a try. See, brute force is normal. Okay, brute force is normal. What you can do is for every stack, that is for every pop, you're going to check whether you can have two sides, whether you will pop it or not. Okay, just like this, what I'll tell you. See, BCDA, right? So this was a B, And what happened on C? I just popped it out. But what if I don't want to pop it out? I want to keep it as C. Then I make it D. Then it gets popped out. And then there is a A. Then it gets popped out. So it's basically like you can have multiple stacks from here, but that will give you a TLE or an MLE. Okay. Yeah. Recursively solve the rest and choose the lexically smallest result. So this is a possible thing, but it fails for n greater than 20. Okay. Brute force with memorization. This is what I have done actually. No, not brute force with memorization. I have done a little bit of higher version of memorization. Okay. From brute force to interval DP first attempt. What is the right solution? Okay. So final solution, chained interval DP. What we notice from going from one removal DP to final full collapse DP. अरे बाप रे, क्या क्या समझा रहा है भाई ये लोग. First, it is brute force tries every removal in the whole string and recurses. You notice the same exact substring often reappears in different branches of that recursion. Huh? Any removal only affects its immediate neighborhood. Okay. Everything to the left of the pair and everything to the right never interact until after the removal. Okay. So it makes sense to cast solution for continuous substrings. Huh. I did somewhat similar to this. Okay. Where dp of I of j is nothing but uh, like the solution for s of I comma j. Okay. And from there, what I can do is I can merge I can merge two of them. Okay. So that is also possible. But that won't be the case for this. हाँ s dot substring हाँ ऐसे किया था मैंने. I don't know whether I can show you my one of my submissions. But वही है ना कि अगर मैं दिखाऊंगा तो ये हो जाएगा. हाँ दिखाऊंगा तो वो हट जाएगा और वापस लैग कर जाएगा मेरा वीडियो. You remove exactly one adjacent consecutive pair s of k and s of k plus 1. So this is okay. This is normal. Okay. dp of I of k plus dp of k plus 2 comma j. Okay. This is what you get after removal of that one specific element. Okay. The DP only ever does one removal per interval. If that removal creates a new removal adjacency across a split point, example BCD, removing CD intervals splits into B and A. So DP04 sees BA as final and stops, never removing BA. Acha. Right. Okay. So this is a flaw. Now see, removing CD in BCDA gives BA and then BA must go to. Our first DP never looked at the second step. Because once it removed CD, it treated the left and right as finished. Okay, it treated the left and right as finished. If everything between two characters can collapse to nothing, those two characters become adjacent in the final sculpture and you must consider. Cleaner, more exhaustive choice is to uh, layman simple options for dp of I of j is keep the first character s of I, then solve the rest dp of I plus 1 comma j. Okay, got it. Keep the first character and change all the remaining characters. Great, great. Then remove s of I by pairing it with some other later s of k. But we can only do that once the entire middle chunk has been completely collapsed, right? Otherwise, they are not truly adjacent. What he means is like BCDA. So I can collapse. I mean I can remove B and A only if everything in between it gets collapsed. Okay. So why this feel obvious in hindsight? If you want to decide the fate of every character in the first in the piece of string, either it ends up in a final answer or it doesn't. If it does, your track is on front and worry about the remainder. If it doesn't, must have married someone somewhere down the line. Okay, okay, okay. And that marriage only happens once everyone in between has already left town. Okay, okay. So just try to imagine like this: like B and A wants to marry each other, but they can't marry until C and D has already left the town. So like if C and D marries each other, then only B and A can marry each other. Okay, so this is how the conditional thing comes. You automatically explore keeping the characters forever versus pairing it off at every possible partner. So what the DP status to be like, keep S of I, the result is equal to S of I plus DP of I plus 1 comma j. Try removing S of I and S of k for all k of I if DP of I plus 1 comma k is equal to 0. Meaning between I plus 1 and k minus 1, it can be fully removed. Okay, then only you can remove I and k. Then S of I and k, that will be that. And result is equal to minimum of result comma DP of k plus 1 comma j. Because you know, like, for from I to k, okay, I to k, now it is removed, everything is removed. So what do you need now? You need dp of k plus 1 comma j. Earlier what we were doing is, we were not using this, we are not using this s of I separately. Okay, now we are using it separately. ठीक है, earlier we were not using it separately. तो अभी बहुत सिंपल है. It's like ऐसे देख लो, if okay, absolute a minus b absolute a. So this is basically is consecutive, and then what he's doing is, he's just going through all the elements and then again checking for all the elements, and j is equal to I plus length, and he's keeping the s of I plus dp of I plus 1 comma j, because that is what it will be happening. Then now we have to try to remove this s of I if it is possible. So for every k which is coming after I and between j, I mean less than j, we are going to check if every element between them has left the town or has been married. Okay, then only they can marry, right? So now what happens is consecutive if both of them are consecutive, and dp of I plus 1 comma k is equal to 0. I mean empty string. Okay, yeah, empty string, because like there is no one in between. Then only they can marry, right? If there is no one in between, then they marry out each other, and then result is equal to minimum of result comma dp of k plus 1 comma j. So this is basically nothing but this empty string plus dp of k plus 1 comma j. Okay, so this empty string is nothing. So that's the reason we can directly go for dp of k plus 1 comma j. Okay, this is I mean like a little bit complicated, but easier to understand than C, I guess. Like if you watch down whatever happens in this, then I think it's easier. But yeah, it is not something that can come up in your mind uh, within just 3 hours also. Okay, it will take you more than 3 hours to come up with this solution, and maybe you won't be able to do that because your brain gets exhausted too much. So whoever has done this, it's a damn good job. Whoever it is, Harsh, it's a very good job, and the way he has explained it, that's also very good. Yeah, time formula is big O n cube, right? Big O n square dp state, big O n of k different space formula big O n square, because the dp is of big O n square. Someone has wrote magnificent. Yeah, exactly, man. This is really good. The way he has explained it is really good. I don't know how to upvote up. There's okay. Okay, so let's do one thing. Let's read the problems. For today's contest, we will be going with only three categories: hard, easy, and medium. Okay, why is it so? I'll tell you. Hard, medium, because A was easy, B was easy, C was hard, D was hard. There actually even this medium won't be doing anything. Okay, ये भी एकदम पूरा blank ही छोड़ो. So it was like AB was easy. Now I know that B was given as medium, but चलो ठीक है. Like if you understand कि हाँ भाई stack ऐसे बनता है, ठीक है. For our like we can do one thing. We can keep B as medium easy. मीडियम इजी पे डाल सकते हैं हम लोग, ठीक है. सो ओके ब्रो गाइस, दैट्स इट फ्रॉम माय साइड, दैट्स इट फ्रॉम माय एंड. ओके, चलो मिलते हैं नेक्स्ट स्ट्रीम में. चलो गुड नाइट. आई मीन नींद आ रहा है भाई मुझे. चलो बाय.